Hi everyone, we are the Group 4 and our topic is all about geology and non-renewable mineral resources. In this topic, we're going to discuss about number 1, what are the Earth's major geological processes and hazards? Number 2, how are the Earth rocks recycled? Number 3, what are mineral resources and what are the environmental effects of using them? Number 4, how long will supply of non-renewable mineral resources last? And lastly, number 5, how can we use mineral resources more sustainably? So our first topic is what are the Earth's major geological processes and hazards. The Earth is a dynamic planet. First, we're gonna talk about geology. Geology is a science devoted to study of dynamic processes occurring on the Earth's surface and its interior. The three major concentric zones is the crust, mantle, and core. The core is the Earth's innermost zone, extremely hot, with a solid inner part encircled by a liquid core of molten or semi-solid material. Surrounding the core is a thick zone called the mantle, solid rock, but under its rigid outermost part is the asthenosphere, a zone of hot, partly melted rock that flows. The outermost and the thinnest zone of the Earth is the crust, and there are two types of crust, the continental and oceanic crust. Continental crust, which underlies the continents, oceanic crust, which underlies the ocean basin and makes up 71% of the Earth's crust. The combination of the crust and the rigid outermost part of the mantle above the asthenosphere is called the lithosphere. I will show you a picture of the major features of the Earth's crust and the upper mantle. The Earth beneath your feet is moving. Convection cells or current move large volumes of rocks and heat loops within the mantle like gigantic conveyor belts. Flows of energy and heated material in these convection cells cause the lithosphere to break up into dozens or so huge rigid plates called tectonic plates. Continents have split apartment and joined as tectonic plates drifted atop the Earth's asthenosphere. The forces produced at this plate boundaries can cause earthquakes, erupting volcanoes, and mountains to form. Oceanic plates move apart from one another, allowing magma to flow up between them. Much of the geologic activity at Earth's surface takes place at the boundaries between tectonic plates as they move in resulting cracks. Oceanic ridges may have peaks higher than canyons deeper than those found in the Earth's continents. When two oceanic plates collide, a trench ordinarily forms at the boundary between the two plates. When oceanic plate collides with the continental plate usually rides up over a denser oceanic plates and pushes it down into the mantle in a process called subduction. So the area where this collision and subduction take place is called the subduction zone, and tectonic plates can also slide and grind past one another along a fracture or fault in the lithosphere, a type of boundary called transport fault.
The Earth's crust is made of a mosaic of huge rigid plates, as you can see in the diagram. And here are the Earth's major tectonic plates.
So now, let's proceed to volcanoes release molten rock from the Earth's interior. An active volcano occurs where magma reaches the Earth's surface through a central vent or a long crack, what is called fissure. Many volcanoes form along the boundaries of the Earth's tectonic plates when one plate slides under or moves away from another plate. Magma that reaches Earth's surface is what we call lava. And now, I will post or present a picture, and it is all about the internal pressure in a volcano can cause lava, ash, and gases to be ejected. So here's the picture. let's proceed to earthquakes are geological rock and roll events. Okay, so forces inside the Earth's mantle and near its surface push, deform, and stress rocks. The stress can cause the rocks to suddenly shift or break and produce a transform fault or fracture in the Earth's crust. When a fault forms or when there is abrupt movement on an existing fault, energy that has accumulated over time is released in the form of vibrations, and it is so-called seismic waves, causing an earthquake. An earthquake has certain major features and effects. So here's the picture. Next, let's proceed to the severity of an earthquake as measured by the magnitude of its seismic waves. The magnitude is a measure of shaking caused by the earthquake, as indicated by the size of the seismic waves when they reach a seismograph. Scientists uses the Richter scale, on which each unit has amplitude 10 times greater than the next smaller unit. So here, insignificant, less than 4.0 on the Richter scale. Minor, 4.0 to 4.9. Damaging, 5.0 to 5.9. Destructive, 6.0 to 6.9. Major, 7.0 to 7.9. And the grade is over 8.0. So last, one way to reduce the loss of life and property damage is to examine historical records and make geologic measurements to locate active fault zones. Map high-risk areas and establish building codes that regulate the placement and design of buildings in such areas. People evaluate the risk and factor it into their decisions about where to live. And last, engineers know how to make buildings and structures. Thank you.
Hello, good morning everyone. Anyways, we are the group 5 and my topic is all about how the Earth's rock recycled. Okay, so there are three major types of rocks. So first, let's define what is rock. It's not the rock, but rock. Rock is a solid combination of one or more minerals found in the Earth's crust. Some kinds of rock, such as limestone and quartzite, contain only one mineral, while most consist of two or more minerals, such as granite, a mixture of mica, feldspar, and quartz crystals. So there are three broad classes of rocks. First is sedimentary rock. Example: sandstone and limestone. Second rock is the igneous rock. Example: granite. Then the third one is metamorphic rock. Example is slate and marble. Then I have a video presentation that I can offer to you to understand well what is the simplified rock cycle. So here's the video, watch this.
The rock cycle. Volcanic eruption. Igneous. Sediment. Sedimentary rock. Metamorphic rock. Magma.
So that's it. That's the video. I hope you understand the point. Earth's rock are recycled very slowly because of the rock cycle is interaction of physical and or chemical process that change rock from one form to another. It takes millions of years for the cycle to happen. So that's it. Thank you very much for watching.
How long will supplies of non-renewable mineral resources last? Mineral resources are distributed unevenly. The earth crust contains fairly abundant deposits of iron and aluminum. Yes, the earth crust contains abundant deposits of iron and aluminum. Aluminum is the most abundant metal in the earth crust, while iron is the second most abundant. Aluminum makes up about 8.2% of the earth crust. It's usually found in compound forms like aluminum sulfate and aluminum oxide. Iron makes up about 5.6% of the earth crust. It's the main component of the earth crust core. Iron is used in the steel making process. Manganese, chromium, cobalt, and platinum are relatively scarce. The Earth's geologic process have not distributed deposits of non-renewable mineral resources evenly among countries. Supplies of non-renewable minerals resources can be economically limited. The future supply of non-renewable minerals depends on two factors: the actual or potential of supply of the mineral, the rate at which we use it. Minerals may become economically depleted when it costs more than it is worth to find, extract, transport, and process the remaining deposits. Options when this occurs are recycle or reuse existing supplies, waste less or use less, find a substitute or do without. Market prices affect supplies of non-renewable minerals. Geologic processes determine the quantity and location of mineral resource. Economics determines what part of the known supply is extracted and used. An increase in the price of scarce mineral resources can lead to increased supplies and encourage more efficient use. Standard economic theory may not apply because most well-developed countries often use subsidies, taxes, regulation, and import tariffs to control supply, demand, and price of the minerals. Most mineral prices are artificially low. Is mining lower grades ores the answer? Extraction of lower grades are the ore is possible due to new earth moving equipment, improved techniques for removing impurities from ores, and other technological advances in mineral extraction and processing. Mining low-grade ores is limited by increased cost of mining and processing larger volumes of the ore, increasing a shortage of fresh water, which is needed to mine and process some minerals, especially in arid and semi-arid areas. Environmental impacts of the increased land disruption, waste material, and pollution produced during mining and processing can use microorganisms that can break down rock material and extract mineral in a process called in place or in situ mining or biomining. Can we get more our minerals from the oceans? Some oceans mineral resources are dissolved in seawater. Low concentration takes more energy and money than they are worth. Hydrothermal or deposits are rich in minerals such as copper, lead, zinc, silver, gold, and some of the rare earth metals. Growing interest in deep sea mining. Manganese nodules cover all large areas of the ocean floor. Good
morning everyone. My topic is all about how can we use mineral resources more sustainably. To use mineral resources more sustainably, we must reduce consumption through finding substitutes, redesigning manufacturing processes, and addressing population growth. Simultaneously, we need to improve extraction practices by employing lower impact mining techniques, reusing mining waste, utilizing eco-friendly equipment, and effectively rehabilitating mining sites while combating illegal mining. Finally, promoting recycle and along with providing financial incentives is crucial for creating a circular economy that minimizes environment damage and maximizes resources